Okay, today's lesson is 44, cross products and slope. What's our objective? Get ready?
Cross products and slope.
Cross products and slope. We're going to do some quick proportions while we solve for a missing number. We're going to talk about slope, positive slope, negative slope, zero slope, undefined slope, and importantly, how does slope have a relevancy in the context of a story problem with rate of change. So quickly, our cross products help us find a missing number in a proportion. Some of you have probably done this before. So what we're going to do to solve this missing number that would make this proportion true, we're going to take the cross product. What will we take? Get ready?
Cross product.
Cross product, it means you multiply from the bottom to the top on one side and the bottom to the top on the other side. So we'll go 4 times n and put it on the left side. I'm going to line up my equal sign and do 6 times 6 on the right side. Then I'm going to simplify. 4n equals 36, and now I'm going to solve for n by using our inverse operation. So to get n isolated, I need to get rid of the 4 by dividing. I keep a balanced equation, do it on both sides, and I get n equals 36 over 4, which is, get ready?
9.
9, very good. Thank you for listening and staying with me. Okay, so let's try this one. M over 10 equals 15 over 25. Our missing number is here this time, but our method will be the same. We take the cross product. What do we take? Get ready?
Cross product.
Cross product. I'm going to write it up here. So m and 25 multiply together. I'll write the coefficient in front. And then equals 10 times 15. 10 times 15. Next step is to simplify. 25m equals 150. And now to isolate m, I would divide by 25 because that would make it cancel or turn into 1. Keep a balanced equation, do it to both sides. M is now isolated. And I think, how many quarters would go into $1.50? Spencer? 6, right? There's 6 quarters. That's just an easy way to, if you think money, sometimes it's easier to divide. How do we know? We think it's 6. How could I be sure that 6 is the right answer? We're on a test, and I really want to check it. Could I put my 6 back into the fraction and do a cross product again and say, hey, is 6 times 25 equal to 10 times 15? It is. 6 times 25 is 150. 10 times 15 is 150. I have an equality, so I know that 6 makes this proportion true. So that's a good check step. Okay, now we're going to shift gears. We're going to talk about slope. Some of you have probably heard the word slope before. Truckers use slope, but they have a different word for it. It's called grade. They are driving along the canyon road or a hill, and they see a grade sign that says you have a 15% grade coming up, or a 10% grade. What that means, in math we know percent means per 100. It means they have a 15 per 100 grade, meaning for every 15 feet of vertical relief, there's 100 feet of horizontal. So their truck is driving on a road that steep, 15 to 100. So a 10% grade would mean maybe a 10 foot, I'm not really quite to proportion here, but my truck's driving, maybe it's going uphill, okay? 10 feet of relief to 100 foot horizontally. Notice the vertical part is on top, the horizontal part is on bottom. Maybe we have a name for that in math. We call it a rise, and we call it a run. So our grade in math, we call it the slope. What do we call it? Get ready?
Slope.
Slope. When you think of a ski slope, it's got steepness, right? There's different levels of slopes. So the steeper the slope, the higher the number. Well, what is the number? Well, we always do a fraction, the rise over the run. What is the slope? Get ready?
Rise over the run.
The rise over the run. Just like this is a rise of vertical and a run of horizontal. A rise over a run. A rise over a run. So truckers we're always going to go left to right the way we read. So my truck's going to drive up this hill. If the truck's driving uphill, we say it's got a positive slope. What slope does it have? Get ready?
Positive slope.
Positive. If our truck is going downhill, we're going to say it has a negative slope. What's a downhill slope? Get ready?
Negative slope.
Negative slope. So now we have a concept of idea of what is slope? It's steepness. It's the rise over the run. Sometimes we call slope a rate of change. Think of it's like how fast is the y changing compared to the x? Is it changing a lot? Or is it changing just a little bit? So that's the way to think of slope is rise over run or change, or rate of change. All right, so let's find the slope. This is where it gets really fun. I love doing slope. We take a graph. We have some suggested points down here, or some known points, 4, 0, and 0, -2. And we're going to make a triangle because we're going to find out its rise and its run. It's a right triangle, right? So let's start with this point, and I'm going to work my way over to this point, but I have to go horizontal and vertical. So I'm going to count by bunny hops, 1, 2, 3, 4. And I went to the right, so it's a +4. From here, I got to go up to get to my other point, so I'm going to go up 1, 2. I went up, so that's a +2. So my slope, which equals rise over run. What does slope equal to? Get ready?
Rise over run.
Good. Rise over run. My rise was +2. My run was +4. And then my last step is to simplify. 2/4 would equal 1/2. And the positives I don't need to write. +1/2. Okay? Give me a nod if getting it. So far, so good. All right, let's try another one. Let's do this one. I'm going to give a point here and a point here. I'm going to show you, you don't always have to draw your triangle underneath. There's another triangle above. Here's my right triangle. See the triangle? So I'm going to go from the left one to the right one. And again, I'm going to go bunny hops, 1 segment, 2 units, 3, 4, 5. I went up, so I went +5. This one time I'm going to go 1, 2, +2. And I'm going to end up there. So my rise over run is equal to a +5 over a run of +2. This one is tempting to make a mixed number out of it, but we never make a mixed number in slope. Just reduce it if it can reduce. But I can leave my slope as 5/2. So it means for every 5 feet I go up, I only go 2 feet over. That's really steep for a truck. Lucas.
Can you ever go negative, like -2 or -5?
Yes, we're going to do that on the next one. So a great question. All right, so this line is going to have a little different part to it. So let's put a point on the given suggested points here. We're going to make a triangle. Let's do this triangle. Okay, let's find rise over run. What does the slope equal to? Get ready?
Rise over run.
Rise over run. So my rise, if it helps you think of a balloon rising, it rises up and down. It runs out of helium and it'll float down. A runner, there's your rise. A runner is going to always run on the ground, right? Here's my runner. Okay, he's running left and right. All right, so let's start from this point and let's work our way over to the other point. We are only allowed to go vertical or horizontal. So we're going to bunny hop. 1, 2, 3. I went down, didn't I? If I go down, my rise is negative. So now my balloon's falling. It went down. And now I'm going to run this way. 1, 2. I went to the right, which is positive. I went +2. So my rise over run. My rise was -3. My run was +2. And I don't really have to write both the negative and the positive. I can just write a negative out in front because the negative will always beat a positive, right? Jacob.
So, is this how, like, when you're, can you use this to, instead of trying to use the Pythagorean theorem to find the hypotenuse, could you use this to?
No, but that's a great question. So his question is, will this help us find the hypotenuse? Now think of, in Pythagorean theorem, it's finding a length. We're not going to use slope to find length. We're going to use slope to find how steep it is. But that's a great question. Make sense?
Mm-hmm.
Okay, Hiram?
Would you ever use the negative one? 'Cause it's not like people, like, drive upside down.
When would we ever, any line that's ever going from the left side to the bottom right side, there will have to be a negative somewhere. Let me show you one other case, okay? I want you to open your minds a little bit and stressed out some of the kids in last period. Could I draw my triangle right here?
Mm-hmm.
Okay. If I go from this point to this point, can I go, oh, I'm going to reverse it. Can I go from this point to this point?
Mm-hmm.
Yes, it's allowed. So this time if I bunny hop 1, 2, 3, did I just go up?
Mm-hmm.
Did I go +3? Uh-oh. Uh-oh, but keep waiting. You're going to see what's going to happen. Now I'm going to go to the other point. I'm going to go 1, 2, but I went left. I went negative 2. So is my rise over run positive 3 over negative 2? Are these the same?
Yes.
Yeah, they're the same. So regardless if I go from this point to this point, or this point to this point, you'll get the same answer, so don't worry. But make sure if you're going down, make it negative. If you're going left, make it negative.
Can you only use right triangles instead?
Great question. Only use right triangles. All right, now we're going to do an application. Oh, before we do an application, let's talk horizontal and vertical. If you're a trucker and you're driving along a horizontal line, you're just kind of coasting. There's no steepness to that line. It's pretty easy. So how would we define the slope? By the way, the math symbol for slope is m. How would we define the slope? Well, let's do a quick rise and run. Do I rise at all to get to this point? No, I have a run, but I didn't have to rise. So my rise over my run, I didn't rise at all. And I ran 4 times. The slope of a horizontal line is 0. There's no steepness to it. It's just level and flat. Slope is 0 of a horizontal line. What's the slope of a horizontal? Get ready?
0.
0. What about a vertical line? So I've got my truck and I'm just going, gotta make it. You're not gonna make it. Think of it, this is like not possible. The slope of a vertical line is undefined. It's so steep, we can't even describe how steep it is. It's impossible. How would we show it mathematically? Let's pick 2 points. I need a rise over a run. Well, my rise is ding, ding, 2. My run is, that didn't go anywhere. I can't run, so I have a 0 in the denominator, and now a building is going to explode because you can't divide by 0. So that's why our slope is undefined. What's the slope of a vertical line? Get ready?
Undefined.
Undefined. All right, our last problem for today is a state core standard. I'm going to blow it up a little bit bigger. Okay. It's 8.f.4. It says you should be able to interpret the rate of change. Well, guess what rate of change is? It's how steep the y is changing in relation to the x. So rate of change is really the slope. Can you interpret the slope or rate of change and the initial value, initial is where it starts, of a linear function, this is a linear function, in terms of the situation, here's the situation, using its graph or a table. We've got a graph. Yes, we can. So the question is, can you find the slope from this? Yes, we can. We're going to do it. So we're going to take this point right here. We're going to pick this point. We're going to find its slope. How steep is this line? Well, it's not on the grid. Do I have values for this one? They are there. They're there. Let's look up here. This point would be 3, and I'd come over across here 150. This point is 1. I come over here to 50. 1,50. Oh, I have points. Can I now draw a triangle? And figure out the rise and the run. I totally can do that. Okay, so my rise would be, how far is it from here to here? Well, I knew this was 150. It looks like it goes from 50 to 150. So what is my rise? Get ready?
100.
100. You guys just figure that out because you're staying with me. Thank you. The run is the distance from here to here. Well, it went from 1 hour to 3 hours. So what's my distance or run? Get ready?
2.
2. So my run is 2. Let's put units. This was miles. This was hours. So my rise over my run. Whoa, Alex. My rise over my run. My rise is 100 miles over a run of 2 hours. Always, and I'm running out of room. Let me come back over here. 100 miles over 2 hours. Always reduce your slopes. 100 over 2 is 50 over 1 miles per hour. And we can get rid of the 1. Is 50 miles per hour a rate?
No.
It's actually a speed. It's a rate, right? A rate is a speed. So using this graph, we actually figured out he has a constant rate. He never speeds up or slows down. The whole time he's driving, he's going 50 miles per hour. And that's the slope. That shows how steep his line is. Kind of cool. All right? Any questions on today? Anyone confused? Just need some practice, right? We'll do a little bit of practice at it, and then you'll be like, okay, I'm a pro. All right, we're on page 304.